Welcome back. I'm George. As promised, this is the follow-up video of the one we did for these wires that we described. And that was the 4-wire and 3-wire hookup. So we got 4 wires for 240 volts, or we can use 3 wires for 240 volts, or we can use a combination of these 4 wires for 120 volts, or these 3 wires for 120 volts. So stay tuned. And again, if you're not comfortable with this, you can watch it for the entertainment value, or whatever the case may be. A warning: if you don't follow some basic, simple rules, this could kill you. I have to be perfectly honest. So none of us want to die, at least not. We don't want to get shocked, because that'll make you look funny. All right. So remember, the 120 volts, you got a white, a black, and a green. The green is ground. The white and the black is 120 volts. A hot and a neutral. Okay. Now, on the 240 volt, on the 4-wire, you have, it's 240 volts. You have a hot red, a hot black, both of them 120 volts each, out of phase. A white neutral, and a ground. So you get 240 volts by using these 2 wires as your hot wires. And then, of course, you got the green for the ground. But they don't require a neutral. They equal 240 volts. They're their own neutral. If you use a red wire and a white wire, you get 120 volts. If you use a black wire and a white wire, you'll get 120 volts. Okay. We already know this one you get 120 volts easy by using the white and the black. But you could also use it as a 240 volt, because since 240 volts doesn't need its own ground, or doesn't need its own neutral. It is its own neutral. So you can hook this where the red one would go, and this one where the black one would go. And of course this one just goes to ground. So since it doesn't need a neutral, you're using the white wire as a red wire, and you got 240 volts. That will permit us to wire either the 1500 watt or 2000 watt 120 volt, or the 3500 watt 240 volt. We can do either one. We can actually do both. Okay, let's delve into this so we get a full understanding. Now, this is a sub panel. I've got it set up as a sub panel. And if it was a complete sub panel, there would be an additional bar that I would place in here, and that's a separate purchase. It looks just like one of these. It's just got a bar with a bunch of places to put wires, and that's the ground wires. And you'd mount that on this side, or you'd mount it on the bottom. Of course, just a bar you screw right into the box, and that's where you hook your ground wires to. If this was a main lug center, the very first one after the pole in the house, well, you would actually bond the box, and you could use one side as the ground, the other side as the neutral. But if it's a sub panel, you have to have a separate ground. Now, that's just to make sure I cover all my bases with the electricians out there, because this is very, very important. The only time that you hook a ground and a neutral together is at the main. Your very first input into the house. That's your main lug system. After that, if you're using a sub panel, you'll always need to have that separate ground bus bar. Another topic all in itself. Now, so what this will look like, you see I've got a 100 amp breaker in here already. And this 100 amp breaker energizes these 2 bars. So it goes from off to on, of course. And you'll have the red wire will hook to this lug, the black wire will hook to this lug, and then the neutral wire will hook to this lug. Your ground wire will go to the ground bus bar. That'll be over here. So what we have now is we have 120 volts in, 120 volts in. That means each one of these bars are going to be energized but maintained separately at 120 volts. You follow me so far? I know you're there. So if you hooked a multimeter to this bar and that lug and just tested it, that would be the red and the white, you'd get 120 volts. If you put your multimeter point here and on on the black one and on the white one, you would get 120 volts. Now the same is true on the ground bus bar. If you went from the black to the ground, you'd get 120 volts. If you go from the red side to the ground, you would get 120 volts. That's because of the difference between the two. Now, what's interesting though is if you take both of those leads and put on one bar and put it on the other bar, you would get 240 volts. Okay? And the limit of what you can run through this will be controlled by that 100 amp breaker. So this is known as a 100 amp sub panel. You can have 125, you can have a 200. They come in various different degrees of how much amperage they'll handle. Now all of that's controlled by circuit breakers. Now this one's made by Homelight, you got it made by Square D, you got it made by GE, just whatever, they all work the same way. They may look a different, design a little bit different, but it's all the basic same principle. So just make sure that your breakers match the type of box that you got, or else they won't fit. Now these are known as a single breaker, a single pole breaker. And what's simple about this is it's off or it's on. It's tripped or it's on. And you have the wire that comes here on the bottom. This is the hot wire. And that breaks. See, these will fit. I'll show you this. These will fit. You see this lug? This slides in here. Bang, there you go. And that lug goes right onto there. Now that means that I'm drawing power from this leg because I'm on this lug. Even though that breaker's on that side of the box, it's drawing from this bar. Now my next one that I put in, if I put that here, you'll see that my lug is here. So that means that this breaker is going to pull 120 volts from this bar. This breaker will pull 120 volts from this bar. Got it? Okay. Now, so your hot wire going in, we're working 120 volts right now. You would hook the black wire to this screw on the back of this, or on the side of this. So you would hook that up first, make sure it's turned off, and then plug it in. Your white wire would go to the neutral bus right here. Any one of these screws, they're all together, they all go the same place. And then the green, which is the ground, would go to the green bus bar, which could be here, or could be here, wherever you placed it. All right. Now in this particular case, we have one that's drawing from this side and one that's drawing from this side. Remember, we have to have both sides in order to get 240 volts. If by chance I had this breaker sitting here, okay, and then I take my 4 wires and I hook a red to this one, which means I'm drawing 120 volts from here, and the black one here, which is drawing 120 volts from here, my white one to the neutral bus bar, and my green one to the ground. What have I got? You're right, 120 volts. I've got it on 2 lines though. I just got 120 volts because they're all on the same phase. I got them on the same. But if I left this one connected here, you see now that I'm drawing from here and here. So this one is 120 volts in this phase. This one's 120 volts in this phase. Hook it up the same way. Red, black, white, green. And guess what? I now have 240 volts. It's kind of interesting, isn't it? It's pretty simplistic in its design. So it's not that difficult to wire these yourself or to find back a fault and figure out what went wrong. A lot of times I'll get a phone call, someone will say, well, I've got, I did the 120 volts or the 240 volts and it's just not working. And when I go across the black one in the ground, I get 120 volts. When I go from red to ground, I get 120 volts. I mean, it should be 240. Well, actually what you're doing is you're using 2 circuits from the same bar, and guess what? You're going to get 120 volts from each one. In this way, you're going to get 120 volts from each one. The only difference is that since you're using 2 bars, they add together for 240. In the other case, if you're using the same bar, the best you can ever get is 120. Now they've got a really nifty device out there. It's called a double pole. Now this is a 30 amp breaker. And the 30 amp breaker, you'll notice, has 2 connectors on the bottom, has 2 screws for 2 wires. It's just like taking 2 of these and sticking them together. That's all it is. So no matter where you put it, I can put this one down here, and it is always, all right, now it's going to be that way for me, isn't it? There we go. And it is always going to connect one side and the other side to the same breaker. So when you hook up a red, a black, a white, and a ground, you've got 240 volts that are 120 volts out of phase on each. You got 240 volts total. Now, could you use this as a 120 volt circuit and this is a 120 volt circuit? You certainly could. It's not advised, only because if you blew 120 volt circuit, 120 volt circuit, it's going to shut both of them off. So that's why you have the single pole breakers. And this is a double pole breaker, so that this is primarily used for one item, for like a 200 foot, like your range, or your air handler and your air conditioner, or your heater and your furnace, or something like that. A large item, large appliance that has a lot of draw because it's a 30 amp. That should answer all of our questions. And I mean, it's that easy to put together. Just it's so simplistic, but still very dangerous. In every case, always make sure the main power is shut off. And if this is a sub panel, you might want to go back to the main breaker and shut the entire box off, because just because you shut this off, there's still power here. If you shut the main breaker off, you can do anything you want to in here. But please test it first, just for safety. Other than that, happy brewing, distilling, wine making, whatever it is that makes you happy. And we'll see you on the next video.